All right, welcome back, Hononegah Honors, Algebra 2. Today we're going to start getting ready for our Chapter 13 test. So these are the 13 study guide questions. And so there's lots of things, subtle things to know about each of the shapes. So what I need to know is the first page I got here. So general equation for each of the conics, meaning I need to know what a parabola looks like. Now, granted, there's all kinds of different questions that go along with the parabola, but I need to understand what a general equation for a parabola look like. And then a general equation for a circle. So x minus h squared, y minus k squared equals r squared. So there's the parabola, there's the circle. An elliptical shape. Remember, in an elliptical shape, it matters which one is bigger as to which one the major axis and minor axis are. And then a hyperbola. And there are two of these. I'm only going to write one, but there's two of these. Obviously, if x comes first or if y comes first. So those are all the general equations for each of the different shapes. And so it's good to know, and we will have some questions that things will already be in this form. And then there's going to be some questions in which you'll have to put it in this form in order to find the center and answer all the questions. P is in a parabola, and P is the absolute value of 1 over 4a. So again, if you're trying to find the distance from the vertex to the directrix, or the distance from the vertex to the focus point, you'll need to know P. And so there's three questions that go along with P in a parabola, and so you'll need to know that one. C is how am I going to find the distance from the center to the foci points in an ellipse. C squared equals A squared minus B squared in an ellipse. And then C squared equals A squared plus B squared in an ellipse. So again, the foci points in an elliptical shape are inside the circle or inside the ellipse. Therefore, there has to be a minus sign between. And then the foci points in a hyperbola are outside the vertices, and therefore there must be a plus sign. Another way of remembering it is always the opposite of what the actual equation is. In an ellipse, it's a plus sign in between, so the C is minus, and in the hyperbola, it's a minus sign in between, and therefore it's a plus for the C. All right, so now I'm going to run through all the questions here. There's lots of things to talk about in each of these shapes, so this one's going to take just a little bit, but hopefully it'll get something out of it. Find the vertex, the focus, the directrix, the length of the lattice rectum, the parabola with the equation. Now, the one thing they didn't have here is direction. I think on the test they might have direction as well, but that's not a big deal. We'll just add it at the bottom there. So vertex, it's an x equals parabola. So notice the x value is outside and the y value is inside. So -3, -1 is the vertex point. Now, the number outside the parenthesis, the a value is 2. So therefore, I'm going away 1, right 2, and then 2, 8. And there it is. Answering all the questions now. The axis of symmetry is always an x equals or a y equals line. Since it goes left and right, it's a y equals -1. And yes, you will need that. Direction, we're talking to the right. So this is the one we got on the, and the rest of them require P. So I need to know what P is. P is equal to 1 over 4a, and it's the absolute value of that, but again, it's not necessary in this case, so P is 1/8. The focus is a point, the directrix is a line. So if I went 1/8 from the vertex, I would be at the point -2 and 7/8, -1, because I went to the right an eighth. Then if I went to the left and drew a line, an eighth away from the vertex, you'd be at x equals -3 and 1/8. And then the last thing, it's always 4p. And so 4p in this case would be 4 times an eighth. So we're talking about a half. So the length of the lattice rectum going across the parabola through the focus point would be a half. Sometimes it's not going to be in the correct form for us, and we're going to do a little bit of work here. So I need to put this in vertex form. So the first thing I need to do is take out the a value. Now, this is going to be a little bit confusing to some people, but you're dividing out a negative a half. Therefore, that 4 turns into a negative 8. And so then 8, I would add 4 squared, but on the other side, it's 4 squared times negative a half. So this would be negative 8 on the other side. Y minus 4 quantity squared. Adding an 8, I get 5. So now I have at least put it in the correct form. The vertex is 5 for y and 4 for x. I'm going to go ahead and graph it. It's negative a half. So that means if I go left and right 1, I'd only go a half. So it really doesn't give me a good picture. So left and right 2, or excuse me, up and down 2. 4a, so that is 2. And then anytime I have fractions, a lot of times I go in the increments of the denominator. So I'm going to go up and down 4, which is 16a. So I'm going to go to the left 8. There we go. So that gives me a little bit better picture. Answering questions. Now I know I didn't have direction, but it goes to the left. Axis of symmetry is a y equals line going through the vertex. And the rest of them require p. P is equal to 1 over 4a. So I end up getting negative a half. Remember, it's the absolute value of that, so it's positive a half. So that means I'm going a half away from the vertex. So if I went a half to the left and drew a point, it'd be at 4.5, 4. If I went to the right a half and drew a line, and then the length of the lattice rectum is always 4p. So the length of the lattice rectum is 2. This one's already in the correct form for us. So the vertex is at 3, 6. So I'm going to go ahead and do that. So positive 3, positive 6. It's a downward parabola because it's y equals parabola. So left and right 1, I'd get a half. Left and right 2, it'd be down 2. And then the next one, again, I'm going to go a little further. So 4, if I go left and right 4, 1, 2, 3, 4, I go down 8. The only reason I'm doing that one is because it does give me a little bit better, got an extra dot in there, but better picture. Axis of symmetry would be an x equals line this time. The direction for this one, even though it's not there, it's down. Focus, in order to get the focus, I need 1 over 4p, or excuse me, 1 over 4a. And again, it's the absolute value of that, so you're talking about a half. So if I went down a half, you're talking about 3, 5.5. If I went up a half and drew a line, it's y equals 6.5. And the length of the lattice rectum is always 4a. This time I have to put it in the correct form. There won't be 4 parabola questions. I'm just kind of showing each one of them. Take out a 3. Half of 2 would be 1 squared times the number in front. X plus 1 quantity squared minus 8. So my vertex is negative 1 for x, negative 8 for y. So negative 1, negative 8. A value is 3, so I go left and right 1, I'm going to go up 3. Left and right 2, I'm going to go up 12. Axis of symmetry in this case is an x equals, and the direction would be up, even though that's not asked in a blank. P is required. 1 over 4a, so I get a 12th. So if I went up a 12th and made a point, you're talking about negative 1, negative 7, and a 12th. If I went down a 12th and drew a line, you're talking about negative 8 and 1/12. And yes, you need the y equals. Length of the lattice rectum is always 4a. So 1/3 is the length of the lattice rectum. Next, we got a circle. Circles are a little bit easier than parabolas because there's only 2 parts to a circle. There's the center. So whatever's inside the x parenthesis and whatever's inside the y parenthesis. So we have the center at 3, -1. And this is always the r squared value, making the r value actually just 4. So going over to my picture 3, -1 is my center. And to the right 4, left 4, up 4, down 4. So it's not always going to be in the correct form for you, so you might have to complete the square. So what you do is you take the x squared and the x term and put it together and complete the square. So x squared minus 4x, y squared plus 6y equaling 12. So I get 2 squared, 3 squared. What I add to one side, sorry, I should have added the other. So I should have added 2 squared over here and added 3 squared over there for a grand total of 25. So now the the center is at 2, -3, and the radius is 5. So when I go to graph it, 2, -3, and left 5, up 5, right 5, and down 5. Ellipses, so an elliptical shape this time. Center, very much like the circle, the center is the x parenthesis and the y parenthesis, and that'll be the case also in the hyperbola. So I have a center at 2, 1. Now, under the x is a 48. So left and right, you're going to go the square root of 48. So the square root of 48 is a little under 6. So 1, 2, 3, 4, 5, 6, a little over 6. So that is your left and right, because that is what is under the x. We'll talk more about that when we get to our major and minor axes. Up and down is the square root of 20. So the square root of 20, which is approximately a little over 4. All right. And then I create the elliptical shape. Now, the length of the major axis is always double the longer one. Square root of 48 is 4 square roots of 3. So if I double that, that's 8 square roots of 3. So I went left, 4 square roots of 3, right, 4 square roots of 3, making 8 square roots of 3. Square root of 20 is 2 square roots of 5. So this would be 4 square roots of 5. So that's not very nice that the numbers underneath there were not perfect squares. And then the foci, in order to find the foci, you need c. C squared equals a squared minus b squared. And so I take the square root, I get plus and minus 2 square roots of 7. So now the question is asked, do I add the c to the x value of the center, or do I add the c to the y value of the center? And again, in an elliptical shape, bigger is better. So since the value under the x was larger than the value under the y, the foci points are on the x axis, or excuse me, the major axis is the x, not the major axis being the y. So I add that value to the x of the center. Next, I got to actually complete the square myself this time, so it is not in the correct form for me. Obviously, this adds a degree of difficulty to the question because now I have to be able to take out the a value. 2 squared times 25, I'm adding 100 to the other side. And that would complete the square for x. Taking a 4 out, adding 3 squared to, and then multiplying that times the number in front, so plus 36 gets me 4 y minus 3 quantity squared over 100. Divide everything through by 100. Puts it in the correct form for me. Running out of space here, but I'm going to go x plus 2 quantity squared over 4. Y minus 3 quantity squared over 25 equals 1. So the center is at -2, comma 3. So -2, 3. Left and right, square root of 4 would be 2. That's nice. It's a perfect square. Up and down, square root of 25, which is 5. Again, nice that it's a perfect square. And so, making the elliptical shape. Length of the major axis, I went up and down 5 for a grand total of 10. Left and right 2 for a grand total of 4. And then c. C squared equals a squared minus b squared. So I get c squared equals 21. So plus and minus the square root of 21 is my c value. The y is larger, so I take the center and add the c value to the y of the center. Hyperbola is the last one here. Hyperbola, just like the other ones, whatever's in the parentheses. So the x is -5 and the y is +2. So -5, +2. Under x is 25, so I'm going to go left and right 5. So 5 to the right, 5 to the left. Under y is 4, so the square root of that, I go up and down 2. But instead of this now being like an elliptical shape, it actually makes what I refer to as an asymptotal box, the diagonals of which are the asymptotes. And then because the x comes first, so in a hyperbola, being first is more important than being bigger, even though the x is end up being bigger, it's more important that it's first, and so it's left and right hyperbola. Vertices. Now I got to establish how much left and right did I actually go when making those two dots on the box. Those two dots are the vertices of the hyperbola. So I went plus and minus 5 on the x. Again, being first matters. I always like to go ahead and, if it's an integer that I'm adding and subtracting, I like to go ahead and do that. You don't have to. Foci points. In order to get the foci points, you need c. C squared is equal to a squared plus b squared in a hyperbola. So I end up getting plus and minus the square root of 29. The question is, do I add it with the x of the center or the y? Again, because x comes first, and in a hyperbola, that's what matters. You get plus or minus, -5, sorry, plus or minus the square root of 29. 2 are the two foci points. Asymptotes now. Y minus the y of the center, x minus the x of the center, and the only thing left to do is the slope. Going back in the original question when you made your box, you went up and down 2, so that's the rise, and left and right 5, that's the run. It may not be in the correct form for us. Now, the question is always, which one do I put first? Do I put the y first or do I put the x first? You always put the positive value first. Now, there is a chance you're going to divide through by a negative. So we'll talk about that here in just a second, which changes things. This actually did not happen in our homework, but it does make for good conversation. I'm adding 1 squared times -9 is -9. And so I'm going to have 16x squared minus 9y squared, 9, parenthesis, y minus 1 squared, equals negative 162. I apologize there. I was looking at it. I'm like, I made a mistake. I added 153, and then I did subtract 9, so it should be at 144. Divide everything through by 144. So I'm going to get x squared over 9, y minus 1 quantity squared over 16 equals 1. This now I should be able to answer all the questions here. The center is at 0 and 1, so 0 for x, 1 for y. My left and right, 3 under x. Up and down, 4. And so that creates my asymptotal box. And then the asymptotes of which, or the diagonals of which are the asymptotes. But the x does come first, so the x comes first. Therefore, it is a left and right, and I horrendously missed my vertex point there. So I'm going to try that again. So it touches the box. Now, let's actually find the vertices. I went left and right 3. Even though the y value is bigger, it's still left and right because the x value comes first. So 0, 1, plus and minus 3. Again, if I ever get integers that I'm adding or subtracting, I go ahead and do that. Foci, in order to get the foci, I need c. C squared equals a squared plus b squared. So in this case, I end up getting square root of 25, which is 5. And again, I'm going to add that with the x of the center. And why did I mess that up there? Sorry, trying to do too many things. Left and right 3 on the x. So hopefully everybody saw that and was questioning it. 3, 1, and negative 2, 1 should have been the correct answer. All right, going back to my C, I'm going to add and subtract 5 to the x of the center. So again, 5, 1, and negative 5, 1 would have been the two foci points. And the asymptotes, it's always y minus the y of the center, slope, x minus the x of the center. You actually don't need the 0 there, but just talking about that. You went up and down 4, left and right 3, so the rise and the run is 4/3. That's section 13.4. Now, 13, now it starts getting more complicated because I'm going to ask you to do everything backwards. And so a sketch is probably in your best interest when doing this. So the parabola with a focus point at 7, negative 10, and a directrix of y equals 2. So when you're graphing this, there's the directrix, and I'll make it a dashed line just so I can tell the difference. And then 7, negative 10. 7, negative 10 is the focus. So I still don't know the vertex, but the vertex would be halfway between these two. So we're talking about a y equals negative 2 line and 7, negative 10. And so if I wanted to find the halfway point between those two values, it'd end up being 7, negative 6, because that would be 4 from one and 4 from the other. So 7, negative 6. It's a downward parabola. So we're talking about a y equals x minus 7 squared minus 6. That's what I know so far. And then the next thing I need to figure out is what the a value is going to be. The p value from the picture is 4. And p is equal to 1 over 4a. So 4 is equal to 1 over 4a. And now I can calculate this equation for a. And notice I went ahead and put a negative 1/16. It's 1/16. And because it's downward, it's a negative 1/16. So again, all the different things about the parabola here that you did before when you were given the equation, you are now trying to figure out how to write the equation. Another parabola, another focus and directrix. So making a little sketch, negative 4, positive 4. So negative 4, positive 4. X equals negative 2. And so I want to find the vertex. I want to find right in between the focus point and the directrix. So you're talking about the point negative 3, positive 4 is the vertex. And this would be a left parabola. So we're talking about an x equals y minus 4 squared minus 3. So again, putting the vertex into the equation. The only thing I have left to do is find a. P is equal to 1 over 4a, and in this case, P is 1. So if I multiply both sides by 4a, a is a fourth, and because it's going to the left, in my picture, we're talking about negative 1/4. An arch is 8 foot across on the ground level. The arch has a vertex at 0, 0, and a focus at 0.5 below. So I have an arch. This point, the vertex is at 0, 0, and the focus point is 0.5 below. So that tells me my p value. My p value is 0.5. Write the equation that represents the cross section of the arch. So we're talking about a y equals parabola, and it's now if you want to put the vertices in because you want to make sure that you understand the vertex, but you don't need it because it is 0, 0. So p is a fifth, or excuse me, p is 0.5, and so 0.5 is equal to 1 over 4a. And so a is a half, and because it is downward, we're talking about a negative a half. The question then becomes, how high is the arch if it's 8 feet across the bottom? So it's 8 feet across the bottom, meaning it's 4 to the left and 4 to the right. So if I plug 4 into this equation, I end up getting negative 8. And so the height of this, it's 8 foot high, which is kind of a coincidence. It's 8 foot across, and it's also 8 foot high. Write the equation of a circle with endpoints of a diameter. Now, they're assuming that you know a couple of formulas. So again, these are kind of, I'll say, things you need to know. The distance formula between 2 points is x1 minus x2 quantity squared and y1 minus y2 quantity squared, and the midpoint formula. Add the x's and divide by 2, add the y's and divide by 2. So these are things that they were expecting you to know from your previous math classes. So let's find the center. Add the x's, divide by 2. I get 4 for x. Add the y's, divide by 2. I get 3 for y. So I'm talking about an x minus 4 squared, y minus 3 squared equals, and now I got to figure out the radius. The radius is the distance from the center to one of the endpoints. So one of the endpoints of the diameter. So if I want to find the distance, I would go y or x minus x quantity squared plus y minus y quantity squared. So I end up getting 36, and this one is 64. So I end up square root of 100. And so that is the radius. The radius is 10, which means actually over here you would put 100. Write the equation of the endpoints of diameter. So this is exactly the same question, so I won't do those formulas again. I want the midpoint first. So I end up getting -2, -6 for my center. So x plus 2 quantity squared, y plus 6 quantity squared equals, now I got to find r squared. This one's an interesting one because you're going straight across. If you actually made a sketch of this, you're talking about -2, -6, -11, -6, and 7, -6. So that actually makes it easier. I don't even need the distance formula to know that this is 9. And so the radius is 81. If you did actually do the distance formula, you would get the same thing. So from the center to one of the endpoints would be a distance of 9. Write the equation of elliptical shape. So I already know what the general equation for an elliptical shape would look like. The major axis is at 5, -1, and a -11, -1. So 5, -1, -11, -1. So I need the midpoint there to actually come up with the, and then the -3, -7, -3, +5. So regardless of which way you looked at this, the center is at -3, -1. So x plus 3 and y plus 1. So if this is at -3, -1, and going to the left is at -11, -1, then how far is it from the center to a vertice point? It's 8, so under x is 64. How far is it from -3, -1 to -3, -7? It's 6, and so under y is a 36. Write the equation of a hyperbola. Now in this one, you do know that it's a minus sign, but you actually don't know the letters yet, because what comes first is depending on if it's an up and down hyperbola, which means the y would come first, or if it's a left and right hyperbola, then the x would come first. So let's make a sketch here. We got vertices at 0, 8, 0, 8, and -6, 8. So those are our vertices. So we're talking about a left and right hyperbola. So I know this is an x and this is a y. Foci points at -8, 8, and 2, 8. So the distance, I'm sorry, and then the center. So the center between those two would be at -3, 8. So -3 for x and +8 for y. Then c squared equals a squared plus b squared. Well, I do know the distance from the center to a vertice. So from -3, -8, or -3, +8, to 0, +8 has a distance of 3. So under x is a 9. And then also, I also know the c value, because going from 3, -3, 8, sorry, to 2, 8 has a distance of 5. So 25 would equal 9 plus b squared, which makes b squared 16. So one more of those. Oh, this is section 13.5. All you have to do in this section on the test is basically tell me the shape. So when I'm looking at it, tell me if it's a parabola, an ellipse, a hyperbola, or a circle. And it's going to be listed there up in the top so you know how to spell it. So let's talk about the first one. There is an x squared, but there is no y squared. Therefore, that is a parabola. The second one has an x squared plus a y squared with the exact same lead coefficients. That's a circle. When I put both the x squared and the y squared on the same side, it's a minus sign, which makes it a hyperbola. Next one, x squared and a y squared, but the coefficients in front of them are different. That makes it an ellipse. Second one has a y squared, but it does not have an x squared, which makes it a parabola. X squared and a y squared, but different coefficients. And the last one, if I put the x squared and the y squared on the same side, I'd have a hyperbola. Please make sure that you're studying for your test. This can be a complicated one if you've not necessarily been paying attention or doing your homework assignment. So I'm hoping you'll get something out of this video. If you have any questions for your teacher, please make sure that you ask, and good luck.